Very good morning to all of you. We are continuing this lecture number 39 to 40. Okay, I think hope so you are there. Okay, don't leave the class. We have seen in the previous class about the sudden expansion of the joint and sudden construction of the joint and the head loss for these two minor losses. Okay, now here in lecture number 40, we will see. Okay, so make this table first, table 1, that is minor losses in pipeline, minor losses in pipe flow problem or pipeline. Okay, so what are these minor losses? You can write down the first one. So I'll write down the first here, the serial number, type of loss, type of loss, type of loss, and then the value of HL, that is value of head loss due to minor losses. Okay, okay. So we will write down first. First is sudden expansion. We have calculated sudden expansion, and the value of HL we have find out B1 minus B2 whole square upon 2G. Okay. Second loss we have find out, that is second loss, sudden contraction. Sudden contraction or expansion between the venoconstrictor to the pipe. So sudden contraction, this also we have find out, and the value of HL is here V square upon 2G in bracket 1 upon Cc minus 1 whole square. Okay. Then third one, if you write down entry to the pipe, entry loss to pipe. This is also minor loss. It can be, it is nothing but 0.5 times of V square upon 2G. V square upon 2G. And another loss due to exit to the pipe, exit to pipe, and it is taken as V square upon 2G. V square upon 2G. Okay. Then fifth one, bends, fittings, etc. Bends, fittings, etc. The loss is K times of V square upon 2G, and the last one, the sixth number, is the loss due to the nozzle. If you provide a nozzle into the pipeline, then that is 1 upon Cv square minus 1 into V square upon 2. So these are the minor losses you have to make in tabulated form in your notebook. The column number one is serial number, column number two is type of loss, and when the head loss due to the sudden expansion, sudden contraction, entry to the pipe, exit to the pipe, belts and fittings, K time is variable to the and nozzle. Okay, and major loss, the major loss is nothing but major loss is start CV spec loss, that is HF is equal to FLV square upon Ag into. Okay, so these are the minor and major losses, and based on that you have to find out the solve the problem. And the values of K, this in case of bends and fittings and etc., the values of K, you can write out the value of K uh, is equal to 0.9. This is for 90-degree elbow. To provide a pipeline 90-degree elbow, and the value of K is 0.49, and K is equal to 5.6 for gate wall. Gate wall we are using in the pipeline. Gate wall half open. Half open. Value of K is equal to 0.2 when you are for gate wall fully open. Fully open. Okay. Value of K is equal to 10 for for globe wall. Globe wall. This is types of wall. The value of K is equal to 1.5 for the foot wall. For the foot wall. So for the bends and walls, the value of K will be changed. K is equal to 0.4 if the 45-degree elbow. Now, generally the 90-degree elbow, you can say it is like that. Okay. And 45-degree elbow, it is like that. Okay. So it make an angle of 45. If you see this angle is 45. So that's why it is called as 45-degree elbow. The value of K is depend on that. The value of K is equal to 0.9 for the standard T if you are using in the pipeline, and value of K is equal to 1.2 sharp 90-degree bend. So, okay, so if sharp bend is there, bend and sharp is that is different. This I have drawn the figure of sharp bend. Okay, so likewise you can suggest the values of the minor losses in the pipeline, and you can calculate uh, by using this formula uh, for the minor losses. Okay, and if minor losses is uh, if minor losses minor losses is less than 5% of major losses major loss, then it will be neglected. तो अगर माइनर लॉस आपका लेस देन 5% ऑफ मेजर लॉस है तो उसको हम लोग निग्लेक्ट कर सकते हैं Now again you have to draw one figure. That figure is to understand the hydraulic gradient and energy gradient line. So again I will take the two reservoir. It is connected with the different pipelines. So I'll make this pipeline pipe 1, pipe 2, okay, pipe 3, okay, and it is attached with the reservoir. So I will make the reservoir at higher level. This is the reservoir. I will write on this reservoir. I will denote this reservoir. This reservoir 1 having some water level here. Okay, the water level here or liquid level, whatever you can say. And then again the second reservoir, following the fluid from R1 to R2. This is R2, reservoir 2. The water level here, it may be somewhere here. Okay. Now the hydraulic garage line, and we have to draw the hydraulic garage line and this total energy line. So I will first draw the hydraulic garage line. So it will start from here and it will come to this pipe here, pipe section 1. Then here the diameter in expand, it means the pressure will expand. Then again the diameter is less, the pressure will be less, and it will be somewhere here. It will be. So this is nothing but your HGL, this line, the hydraulic gradient line. Okay, hydraulic gradient line. So it is generally from the center line of the your pipe. Okay, the pressure measure from the bottom or center line of your pipe. Okay, so here you can see this, and this one is P1 upon gamma. Here it is P2 upon gamma. Here it is P3 upon gamma from the center line. From the center line. This is changing as the cross section of the this pipe diameter is changing. Okay. Okay. And now then we'll draw the this our so this is there is some difference. So this one is the EGL. One is the energy gradient line EGL, and it is always reducing as the pipe flow proceeds. It is always reducing. Okay. So here some small loss is there, and this loss, if I will write down here, it is the entry loss. It is nothing but entry loss. Here some loss will be there, and this loss is due to sudden enlargement. So I will write down this is loss due to expansion or sudden enlargement. Here again loss is there, and then this is loss due to sudden due to total contraction. And here are sub loss, and this loss is, it is called as exit loss. Okay, exit loss. And you know that the velocity in pipeline 1 diameter is d1. This diameter is d1. Velocity v1. Here diameter d2 and velocity v2. Here diameter d3 and velocity v3. Okay, and L1, L2, L3 will be the length of pipe. So I will write down L1, L2, L3. These are the length of pipe, pipe 1, pipe 2, and pipe 3. So this figure shows the EGL and HGL. The figure for figure this figure number 3. This is HGL and EGL. So HGL is hydraulic gradient line, hydraulic gradient line. Okay, and EGL EGL is the total energy line, or it is also called as energy energy gradient line. Energy gradient line. Okay, so this is your figure. You can draw this one. Okay, so what is the hydraulic gradient line? So hydraulic gradient line is a line representing pressure energy along center line of a given pipe system. So hydraulic gradient line, hydraulic gradient line HGL. HGL is a line representing pressure energy, pressure energy along center line of center line of center line of a given pipe system. Whereas EGL, that is energy gradient line, EGL is a line higher by V square upon 2G, that is kinetic energy, compared to compared to compared to HGL HGL and represent total energy of system, total energy of flow, total energy of flow. And thus it can be written as, you can write down total energy of flow. Eg is nothing but Z dot on head plus pressure head plus kinetic head, that is V square upon 2G, and Hg and Hg represent only Z plus P upon gamma. Here in figure, Z is datum head not shown, not shown. Okay. So this is what about the energy gradient line and the atomic number. Note that the pressure head in larger diameter pipe is higher than the smaller diameter pipe. So it should be note that pressure head pressure head pressure head in larger diameter pipe is higher than that in a smaller diameter pipe. Smaller diameter pipe. Also note that Eg will be always decrease in direction of flow. Okay, this is first. Second, that is total energy line or Eg energy line will always decreases decreases in direction of flow, whereas pressure head it depend on the uh, point where the smaller diameter pipe joins larger diameter pipe. So figure 3 shows entry, exit, sudden expansion and sudden construction loss of energy or energy gradient line, and this figure number 3, all the things is shown here. Entry loss, exit loss, है ना? Loss due to sudden expansion, loss due to sudden construction. And major losses if you write down, that is HF1, HF2, HF3, it depend on the your pipe length, pipe diameter, okay, and friction factor, okay, is HF1, HF2, and HF3. So here we are talking about the minor losses. That's why I have not written that. And but while solving the example, you should consider that. But solving the example, you should consider that. I will give you one example. You can try to solve at your home by using this hydraulic gradient line, or then if not possible, if you solve that, it's okay. If you not able to solve, then we will solve in next class. Okay. So example you can write on and you can try to solve your own, and you have to try to solve at your own if possible. If not, then we will solve in classroom. So write on this example. Yes, I will give the example, and if possible we will solve. Otherwise we will solve in another class. So write on example one. Example on loss of head. Example 01. Write on the question. The reservoir 1 and 2 having a level difference between, there are two reservoirs. Huh? Here it is given the reservoir 1 and reservoir 2 having level difference level difference level difference between free surface between free surface between free surface of water of water of water equal to equal to equal to 5 meter are connected by are connected by are connected by are connected by pipe AB and BC. So they are connected by the pipe AB and BC of of diameter 20 centimeter and 30 centimeter respectively. Respectively. Okay. Length of pipe, length of pipe, length of pipe AB is 300 meter and length of pipe of pipe BC is 200 millimeters. If flow through the pipe, if flow through the pipe, the flow through the pipeline is 50 liter per second. Find also find also loss due to find loss due to expansion, loss due to expansion and and friction factor. Friction factor. Friction factor generally we denote the value F. Okay, and draw draw total energy line or energy gradient line. This is an example which is given based on the that previous I have explained you about this example, this figure, where is shown that figure, this figure, energy losses and the header gradient line. So here three pipes are there, but in our example, in this example, how many pipes are given? Two pipes are there. So you can find out the energy losses. This example you know. So first of all, when the example is given, you have to draw the figure and then you have to solve. So if I will draw the figure here, so how many pipes are there? There is two pipe. Pipe 1 having diameter of something else. Pipe 2 having diameter of something else is connected with the reservoir 1 and 2. So reservoir 1. Because the diameter we know, that's why I know that which one is smaller and which one is bigger. So the reservoir 1 and this reservoir 2. Reservoir 2. Okay. Now you have to draw the energy line, because energy line is always it is reducing as the flow proceeds. The flow from this is the surface. If you this is surface, so there is some small head loss is there. Then here also the loss due to the sudden expansion of the joint, and then here exit loss and the level of the water in reservoir number 2 will be below this line. This is the exit loss. Okay, this is entry loss. All this value I have given in your example. Here it is loss due to expansion, loss due to sudden expansion, expansion. ओके, तो पहले हम लोग ने क्या करना है, जैसे ही हमको ये दिया, एंड देन वी हैव आल्सो गिवन दैट द लेवल डिफरेंस बिटवीन द दिस reservoir 1 and 2, it is given as the free surface level difference between two is 5 meter, 5 meter. Okay, and also length of the pipe 1 and 2, it is also given in example. Okay, length of pipe 1 it is given 300 meter, length of pipe 2 it is given 200 meter. I think so, I'm right. And it is given A, B, C. Okay, and major losses are HF1, HF2. Yeah. So now you can see how many losses are there in this pipe. So here you can see that diameter, this diameter is D1, velocity V1, this diameter of pipe is D2, moving with the velocity V2. Okay, this is the figure you can draw. Now from the figure we will come to know that this D1 is also known. D1 it is given 20 centimeter, and D2 it is given 30 centimeter. All the values have incorporated into this example. Okay, the given values. So when you solve the example, okay, so you have to write down the given values and also draw EGL. So always the energy gradient light is reducing at every section. Okay, due to the loss of energy, loss of head, due to the friction, due to the entry, due to the exit, due to the sudden expansion. Okay, so that you have to do. Now if I will write down for your hint how many losses are there. So hint I will write down hint how many losses are there. So I will write down hint. So total difference of head at free surface is 5 meter. So if I will write down to 5 meter, this is the difference. This is different. This difference maybe you can say that P1 minus P2 upon gamma. Okay. So this difference is nothing but 5 meter. The total difference between the reservoir 1 and reservoir 2 it is given 5 meter. So how many losses the difference due to this? First I will start. So first loss is the entry loss. First loss plus second loss is the loss due to head loss due to friction loss. Friction loss due to friction loss HL HF at pipe 1 or in pipe 1. Okay. Plus third one is the, you can see here from the figure, is nothing but the sudden expansion of the pipe. So loss of head due to sudden expansion. Loss of head due to sudden expansion. Plus again the friction loss in pipe number 2. So friction head loss HF2 in pipe 2. And then here the last the exit, only two pipes are there. So hit one the exit loss. Loss. Okay. So this is hint for you, and all these losses we have at the start of over this class we have seen in the tabulated form: sudden expansion, sudden contraction, entry to the pipe, exit to the pipe, bend fitting, nozzle, and major loss due to the friction. Okay, so all this value we know, so you can put this and find out the each value, each losses in this example. First, you can find the entry loss, then you can find the friction loss in pipe 1. Third, you can find a loss due to the sudden expansion, then friction loss in pipe 2, and then exit loss. Okay, so these losses you can find out and then put all this value, then you can able to get the friction factor. So you will try to solve this example your own, and then if you are not able to solve, then we will continue the next class. Okay, so it required time, it will not finish in 1 hour, so that's why we will stop here. And thank you for joining energy losses in the pipe flow problem. So if you have any doubt, you can ask with me, or otherwise we will stop here. Okay, stop here. Okay? ऐसा लगता है कि आप लोग सुनते हैं या नहीं सुनते हैं, डोंट नो, योर कैमराज आर ऑफ. So either you're listening or not, but I will share the uh, yes theory classes and all the lecture sharing on the Google Classroom. Also the video link I am sharing to you on your Google Classroom, so you can benefit from there. So thank you for joining. So if you any doubt, you can share in, or you can write the message in chat box, or otherwise you can write down on WhatsApp group also. So thank you for joining today extra class for 2 hours.